So in the previous session we seen about analog to digital conversion. Now we will see digital to analog conversion. Digital to analog conversion. So here we have to add all the input signals by considering their weight factors. Let's say you have given a binary number, you have to convert it to analog. So the simplest option is using a operation amplifier adder circuit. Let's say you have an adder circuit. Okay, so the output of this adder circuit or negative feedback amplifier is D out is equal to minus B in RF by Rn. Let's say if you have a negative feedback amplifier circuit like this. Output voltage is minus RF by Rn multiplied by Vn. Okay, so we are using same circuit and we are considering all the weight factors. So here I am giving the LSB here. So my B0 is here, B1, B2, B3. So since this resistance value comes in the denominator, I am taking in opposite way. So here the V out is given by what? Minus R by R B0 by 8 plus B1 by 4 plus B2 by 2 plus B1 by 1. So if I multiply with 8 is if I take 180 in common, I will be left with B0 plus 2 times B1 plus 4 times B2 plus 8 times B3. So here we have to maintain proper value for V0. If V0 is chosen to be 8, you will get direct analog signal. equivalent to binary. So V0 is 8, that 8 will get cancelled, we will be left with final result. So here V0 should be given highest weight factor because all the weight factors are coming in the denominator. Okay. So now another method of doing the same is using ladder circuit. It's called an R to R ladder. The same thing can be performed here. Your R and 2R. This is actually an approximation circuit. I mean, just to justify the name R to R ladder. The actual circuit has a little modification. This R is split into two parts and it will be added at the terminal point. We will analyze both the circuits, but we will see that first. Single R here at the input is divided into two parts, 2R and 2R, and is added at both ends. So we will analyze this circuit first, later this, and see the difference. So here in all the cases we have considered R values to be same. So all that matters is the input voltage, right? It will be directly reflected in the output. So I am considering the first branch here. if I have only one bit, so this is the virtual ground for the operation amplifier. This is considered as ground here. And on the other end, actually what happens, these two will be parallel, so it will become half of the 2. It is equal to 1 R. These two portions will end up with 2 R in series with an R. So if you have only B naught in the circuit, I mean only when B naught is on, then this is the circuit. This is equal to R and 1 R. V naught is the input voltage. So the voltage drop at this resistance, at this point is, it is V naught by 3. So total resistance is 3 R. V naught is the voltage. So the effective input voltage V in is equal to V naught into 1 R by 1 R plus 2 R. VR2 by R1 plus R. Fractional resistance by total resistance multiplied by the total voltage. So it is V naught by 3. So if we have only one branch, the input voltage is V naught by 3. Right? So now, if you have only B1 in the circuit, B naught is 0, B2, B3 all are zeros, only B1 is active. Then what is the circuit? This is B1, 2R, R, this is 0, so directly grounded. R, here I am considering D1. So 2R and 2R in parallel will give you R. R plus R is 2R. So you got the previous circuit again, 2R, 2R and 2R. 2R, this entire thing is 2R, this is 2R. So the voltage drop in this entire branch is now V naught by 3. Voltage drop in this entire branch is V naught by 3. All we need is voltage drop in half of the branch, half of this branch. That is another half. It's half V naught by 3. Now if we have only B2, what is the circuit? That is the circuit. This 2R and 2R become R plus R 2R. Again 2R and 2R becomes R plus R 2R. So the voltage drop in the entire branch is V0 by 3. That is now divided between these 3 levels. For level 2 it becomes V0 by 3 to half, and for level 3 V0 by 3 half, again half. So if you have only B3, it is V0 by 3. For B2, weight factor is 1 by 2. Half of whatever value at B3. For B1, it is 1/4 of the value at B3. And for B0, it is 1/8. That is what we got here. B0 with a weight factor of 1/8. B1 1/4 weight factor, B2 half weight factor, B3 1. So technically these two circuits are equivalent. Okay. So now we have to see how things are in this simplified circuit, where we have merged this 2R into here. That's actually an approximation, but still we'll see, we'll analyze that and see what happens. In the first stage, it is simple, 2R and 1R. So output is 1/3. Next case. So next part is a bit complicated. This is 2R, R, so now we have to see the voltage drop, the final resistance R due to this. So what is this value? 2R and R are parallel. It is R1 R2 by R1 plus R2. So it is 2R by 3. This value is 2R by 3. And this portion plus 1. So the total resistance is 5R by 3. So first of all we have to calculate the voltage division between 2R and 5R by 3 and ultimately reach up to the next level. So 2R can be written as what? 6R by 3. So 6R by 3 and 5R by 3. The voltage division is we have to calculate at 5R by 3 by 5 plus 6 plus 3. So it is V naught 5 by 11. V naught into 5 by 11, and that voltage is now divided between R and 2 by 3R. So this 5 by 11 portion is now divided between 2 by 3R and 5 by 3R. So what do you get? R by 3 gets cancelled. So you get 2 by 11 V naught. The expected is V naught by 6. So instead of 1 by 6 you got 2 by 11. That's an approximation. Can even continue for the next level also. Maybe for V1. This is 2R by 3 plus R that is 5R by 3 plus 2R in parallel. This has become 2R by 3 plus R, 5R by 3. So 5R by 3 and 2R in parallel. That is what? R1 R2 by R2 plus R2. 2 can be written as 6R by 3. So in total it is 30 by 11R. Five 6 are 30. 5 plus 6 11. 30 by 11R plus R. So it is 30 plus 11, 41 by 11. By 11R. So that 2R can be written as 22 by 11. Can be written as 22 by 11. So ultimately I have to see the voltage divisions now. So V is equal to V naught times (41 by) So it is 41 by 63. So that portion is now divided between R and 30 by 11R. And 30. It is 11 by 41. Next portion. Five by 11. In total V naught into 2 by 63. What is the expected one? V naught by 12. This is the expected. the voltage divided into this portion. 30/11. By 63 to 11. Expected value is so this is an approximate circuit for R2R ladder, where this R is divided into two parts and become 2R parallel with 2R the other end. So this gives you exact calculations equivalent to this circuit. And if you simplify that, you will get values similar to V0/3, V0/6, V0/12. Near to that. So this is an approximation. This is the exact